Good afternoon and welcome to 12D Model, The Road to Success. My name's Fani McCarthy and presenting with me today is Charlie Dixon. SCIRT's Board and Management identified early in the program what SCIRT is here for, and that's creating resilient infrastructure that gives people security and confidence in the future of Christchurch. The extent of damage from the earthquakes was extensive, with an early cost estimate for repair of $2 to $3 billion. The SCIRT Design and Build project was the biggest New Zealand had ever seen. No horizontal infrastructure works on this scale had been carried out previously in New Zealand. Now, where do we start? We had to get everybody working together. In terms of survey, we had 16 different consultancies working for us, with over 150 surveyors on the books, working on average 5,000 hours per month at our peak. It was obviously essential that all 16 consultancies work together towards our goal, the rebuild of Christchurch's infrastructure. How did we achieve this? Communication was key. We created a survey specification which detailed what we wanted our consultancies to survey and how. This document was ever evolving. It started at 10 pages and grew to eventually become a 40-page comprehensive document. The survey spec was modified after discussions with the surveyors themselves, as well as the SCIRT designers. The designers and surveyors were learning together and communicating to ensure the data provided was in the best possible format to be as useful as possible. The final spec contains a lot of pictures and diagrams to assist the surveyor rather than written detail, because as we know, a picture can be worth 1,000 words. The survey spec was necessary to ensure that the data provided was consistent across the board. In New Zealand, as I'm sure around the rest of the world, the survey community is competitive and not generally willing to share their ideas or information with other consultancies. SCIRT changed that for our consultancies. They collaborated through innovation to work smarter, which resulted in efficiencies and cost savings for the people of Christchurch and the New Zealand taxpayer. An example of this was the 12D drainage macro. This was developed by one of our consultancies and shared willingly with all other survey firms working on drainage jobs for SCIRT. This willingness to share saved SCIRT and the people of Christchurch significant time and money in the asset assessment phase of the rebuild, as it provided a more streamlined approach to data collection in the field and also office processing. Over the last 4.5 years, over 200,000 survey labour hours have been completed on behalf of SCIRT by our survey consultancies. The area highlighted on the map indicates where survey has been undertaken. The types of survey work carried out have included topographic surveys. This is mostly roads and retaining walls. The stormwater drainage network and the wastewater drainage network. This has obviously resulted in a significant amount of data being delivered to SCIRT for use by our designers. Now, how do we manage that data? I've got 3 letters for you. The CED. The CED is the Central Engineering Database. It contains numerous 12D projects with links to the source data, which is updated regularly. The CED is comprised of survey data from the 16 different consultancies, 5 LiDAR datasets, and GIS outputs of utilities, including telecom, gas, power, etc. It is effectively a vault of 12D projects that hold all of the data for a specific discipline, service, or utility. This approach was necessary as there is a significant amount of data involved. The 5 LiDAR datasets, for example, contain over 500 million points each. Therefore, it's obviously impractical for all of this data to be accessible within one project for all users due to the vast amount of data. 12D. Why did we use this software package? When SCIRT started, there wasn't a single surveying and civil software package that was used by all of the people who joined the team. We had at least 4 design organisations, plus the 16 survey consultancies. They were all using various packages and methods for survey and design. It was determined very early on in the program, the first week in fact, that this system would not work and we needed to establish a single platform to integrate all survey and design. We needed a software package that could be used across the board. 12D was it. It had the across-the-board functionality needed, which allowed for a single platform for all main civil design components, as well as survey for the repair and rebuild of the city, delivering a field-to-finish approach. 12D has the ability to import Council's existing GIS information, the pre-quake data. This data was then issued via 12D to SCIRT surveying consultancies, who carried out the condition and asset assessment surveys on the city's roads, retaining walls and the drainage network. Now, once the survey was complete, the data was returned to SCIRT and it was run through a QA process and verified for consistency and accuracy. Now, this was also done in 12D before the data was issued to the designers. In 12D, the designers used the data to help assess the damage to the assets so they could determine if repair or rebuild was necessary. If repair or rebuild was required, design could be carried out in 12D. From the processes developed in 12D, we created the Survey As-Built system, which Charlie will describe for you. On that note, I'd now like to hand over to Charlie, who will talk to you more about the role of 12D for the designers and the birth of the Survey As-Built system. Charlie.
Thank you, Fanine. Designers from different companies using different types of design software would have caused huge difficulties such as inputs, outputs, and capability between software platforms. The one platform, as Fanine described, was used at SCIRT was 12D model. A 12D team working together with some guidance and patience had a chance to deliver the necessary systems to implement 12D model at SCIRT. A team of super users were handpicked, trained to become 12D experts. At the first super users meeting, numbering 6, only 2 people had used 12D model software previously, and this was definitely a challenge. Most had no experience, but each individual was nominated for their personality, their ability to work in a team, being quick learners, and for their focus on helping others. A structure for the data flow ensures designers have the most relevant and up-to-date data. For each project, there could be different designers working on different aspects of the project, for example, one on roading and one on wastewater. Working projects were created for these individual disciplines, with the data being shared out from the master project. Roading, drainage were further enhanced by adding advanced techniques. Contents were boiled down to being comfortable in the 12D environment. Optimization is not an art, it's a process of identifying standards, requirements and outcomes to achieve high quality design and greater integrity of data. Our biggest difficulty was the time frame. Requirements were being drafted at the same time as the training and customization process was being implemented. To ensure our focus remained on the final outcome, we set out some simple goals. What you see is what you get. Introduce logical, intuitive standards. And this led us to the string naming convention, which is the stone on which all other standards are based on, and it allows a great deal of automation within the software. With this in mind, we went about customizing 12D one step ahead of the training and modifying as outcomes and requirements changed. Developing the best customization is nothing when one can't communicate it to the others. Together with the super users, the team produced over 200 pages of documentation that is referred to by all designers during daily work. The documents included 12D model SCIRT standards, how-to documents demonstrating design workflows and detailed information. Therefore, it's all about documentation. Only then could we look at streamlining our process. What is a macro? A series of commands in programming language compiled to make a process easier and efficient. Additional macros were developed which drove efficiency and productivity. The creation of the macros ensured that users were consistent in outputs and were pretty simple to use. Many hours were saved and the frustration in detailed outputs minimized by the use of specific macros. Macros created were developed for disciplines like drainage and roading. One particular macro, the drainage submain, saved considerable time and dollars. The use of macros also ensured that designers were following a correct workflow and create consistent and accurate outputs. Innovation is defined as introducing something new. There are no qualifiers of how groundbreaking or world-shattering that it needs to be. Only that it needs to be better than it was before. Existing as-built requirements for the Christchurch City Council are no longer fit for purpose. These have led to inaccuracies and varying interpretations for data deliverables to Council. The aim of the SCIRT as-built system is to clarify the requirements, standardise the process, simplify data capture, and speed up the process. So, SCIRT developed the Survey as-built system. Its primary aim is to minimise error deliverables. It's worth noting that lessons have been learnt from the Survey Topo process developed by survey managers Chris Scott and Fernine McCarthy. Building upon that knowledge, we didn't have to reinvent the wheel. The system is made up of data capture in field, validation process, deliverables to GIS. Why so great? Because any contractor or foreman can capture data. The Survey as-built guideline, or the SAG, defines the requirements for the contractor and details the deliverables for wastewater, stormwater and water supply networks. Compliance with the SAG is critical to the success of handover information to Council. It's continually being revised and is expanding. The original draft was approximately 35 pages and now over 120 and is still growing. Creation of the document highlighted the importance and descriptive examples. Picture explains 1,000 words, and back to our principle of keeping it simple. The Survey as-built template is really the simplicity of an Excel. The data includes all geospatial and attributed data for both points and lines. There are two components, geospatial data and attribute information. The completed template is inputted into 12D using specific macros for input and validation of data. The outputs are a drainage network, geometry for all wastewater, stormwater and reticulated systems, which are all fully attributed, plots, plan and long sections, GIS-friendly strings, and validation reports. A fully integrated drainage network with correct drainage flow, completely attributed where all segments are connected. This allows the automation of the drafting process and the ability to review data easily. The pits and pipes are attributed as required by the SAG. Plots for review ensures data is easily identified by the contractor. Attributes enable us to highlight differences between design and as-built. These are typically design changes, pipe types, pipe sizes, and pipe grades. A segment number is used as a line reference in the SAT. This ensures full traceability of data and speeds up the review process. Another tool for the review is using perspective view for clash detection. This clearly indicated conflicts such as crossing pipes and null values. A validation report. Comparisons between design data versus as-built data. Simply, what's different from the design to what's actually been constructed. A report is generated which highlight the differences. Pit names, pit chord differences, pipe inverts and grades, comparing design grade to as-built grades. The contractor is able to compare easily design data and as-built data side by side in the as-built report. This process developed further as GIS integrated a validation process using FME, where plan and long sections were required as the outputs from 12D. Finny and I would like to thank you for viewing our presentation 12D at SCIRT. Thank you.